MAP4C 7.0 Mortgages and Annuities Introduction. So what we're going to do is look at simple interest and compound interest. Now, interest is accumulated when money is either lent, like for example, when you get a car or a home, maybe you're starting a business. When a bank is lending money, then they will expect that payment plus an additional interest. Also, you can invest into a bank. When you put money into a bank, they can use that money for different services in order to accumulate interest, and then you and the bank both earn a share of that interest that's been accumulated. So I may be using the lending and borrowing interchangeably. This applies to both simple and compound interest. So let's start off with simple interest. Simple interest is money earned on the starting principal. Now, this term principal refers to that original amount of money that was deposited for a period of time. So it's a lump sum all at once. I is equal to PRT is the formula for simple interest, where I is the dollars earned in interest, P is the original amount that is deposited, think of it as the principal, R is the annual interest rate as a decimal, and T is the time in years. In addition, we have this formula A is equal to P plus I because this formula just tells you how much interest was earned. Altogether in the account, you would have your original amount of money plus the interest that is earned. So for example, Alan invests $1,000 into an account that earns 5% simple interest for 4 years. Use the formula to calculate the interest earned in 4 years. So using the guess method, we are given this information in the question: the principal, the rate as a decimal, and the time. So the unknown part is how much interest has been earned. The formula is I is equal to PRT. And then we substitute in with our given information and solve. So the interest earned was $200 for this period of time, 4 years of investment with $1,000 at 5% simple interest. Next question, what total amount will Alan have at the end of 4 years? So we're given the principal and the interest, and we can figure out the amount. So I always start off with what are they asking for, the amount, what formula do I know involving the amount, what's given, what's unknown, and then substitute and solve. So we end up with $1,200 altogether at the end of that investment. So if we were to model this using a table, in the first year we start off with $1,000. The interest earned is 0.05 times 1,000, which will give us 5% of the principal, $1,000, which is $50. So notice that the ending balance at the end of the first year is $50, $1,050. The starting balance of the next year will always be the ending balance of the previous year. And the interest calculation will always be based on the principal amount, the original amount that was invested. This is an important characteristic of simple interest. It's always based on the principal. So notice it's going up by the same amount each time. And notice if the year is going up at equal intervals, the amount is going up at equal intervals, we should expect a linear relation, and we'll investigate this shortly. Compound interest is money earned on both the principal and previous interest. The formula is an exponential formula because the variable n is in the exponent, where A is the amount of the investment, and this is equal to the principal times 1 plus I, which is the interest rate per compounding period as a decimal. And make sure that you follow along for the different compounding rates or intervals, because this variable will be affected. Also, n, which is the number of compounding periods, will also be important. Let's take a look at the following. What is a compounding period? Interest is usually expressed as an annual percentage rate. So you might hear vehicles say, we're selling this with 0 APR, meaning there's 0 annual percentage rate. However, there are different compounding periods. So this is letting you know the number of intervals or times that the interest will actually be calculated. And let's use a highly divisible number like 12%. If we took a compounding interval to be annual, that would mean at the end of the year we charge 12%. If we were to look at semi-annually, that would mean that that's twice a year, and we could do 6% at the midpoint and then 6% at the end, and the total percentage charge is 12%. Quarterly, monthly, semi-monthly, bi-weekly, weekly, daily. Make sure that you're familiar with each of these terms. One surprise is that if we were to charge, think of this, 12% of a number at the end of the year versus 6% halfway through and then 6% at the end, which amount would earn more interest? Technically, this semi-annual compounding interval would charge more interest because the first 6% would accumulate at the 6-month mark. You would have 6% interest added to the total amount. And then the second time that you charge interest, you have 6% of the original amount plus the interest is also applied on the earned interest or accumulated interest. So it's a very slight difference, but when you're talking about a large amount of money, such as the mortgage for a home, these small factors can play a huge difference. So let's get back to compound interest. Becky invests $1,000 into an account that earns 5% interest compounded annually for 4 years. So that means that interest is being calculated at the end of the year annually, and this is happening for 4 years. So, P, the principal amount is $1,000. 5% per year compounded annually, that's just going to be 0.05 at the point in which interest is being calculated. For 4 years, there are going to be 4 times that interest is calculated because it's once a year for 4 years. Substituting into our formula, we get the amount. So make sure that you check on your calculator order of operations first. I just type in 1.05 to the 4 equals times 1,000. That might work for you. If you have questions, please let me know. How much interest did Becky earn in 4 years? So we know the amount using this formula. But if we're looking for how much interest has been earned, that's the increase in the amount. So how much interest did Becky earn in 4 years? We have the amount as this that we calculated. The original principal was 1,000. So rearranging that formula, A is equal to I plus P, we can isolate the variable I. That's our unknown. And what we need to do is, substitute and solve. If we take the amount minus the principal, that difference is the interest. And this should say interest, my apologies. So the interest earned was $215.51 over this 4-year period. So looking at this table, this will give you a better feeling as to how the interest is being calculated. So that being said, we start off with $1,000 at the beginning of the first year, and 5% of that original amount is $50. We add that to our amount. This is our total. We start the next year with the same amount as the previous year, and then we end up with $52.50. Notice the difference, key characteristic of compound interest is that the interest is being calculated based on the total amount that has been accumulated. So not just 1,000 every single time like we saw in the simple interest formula. We are doing 5% based on what amount was at the beginning of this period. So this includes interest that has been earned throughout the investment. So the difference being, we can see the interest each year increases because the interest is calculated using both principal and previous interest. If you look at the graph of each of these, this is just for the first 10 years, and this difference between the simple interest, which is a linear relation going up by equal intervals, this is for a compound interest investment. So it's going up at a bit of a quicker rate. Now, this doesn't look significant, really. Looks like the difference of about $1,000, but I wanted to look at this over a longer period. Notice that this exponential growth starts to make a larger difference over larger periods of times. So therefore, there's investments such as RESPs and RRSPs, which are for your child's education or for your own retirement, that over a longer period of time will have a significant benefit. So let's take a look at present value. And the principal that must be invested today to obtain a given amount in the future is called the present value. So what amount needs to be invested now to earn a desired amount in the future? And all that this formula is a rearrangement. They've called the investment, the principal, the present value, because that's what it is when you start. That's the value now. And the future value is what it will become at the end of the investment. So I don't like that they treat this like it's a separate concept. It's really just a compound interest formula rearranged. You will see maybe in the future that present value is another name for principal and future value is the amount. Just be aware of that. Rearranging this using opposite operations, divide by this expression on each side to isolate P, because we want to know the present value. And then just putting this on the left-hand side and switching this over to the right-hand side, we end up with this expression. Notice that the negative exponent was used just to be able to not have to write this expression in the denominator. All right, what principal should Cedric invest today at 4.6 per year, compounded semi-annually to have $6,500 3 years from now? So the amount is $6,500. That's what we want to have at the end of the investment. This is our first opportunity to look at changing compounding calculations. Semi-annually refers to how many times it's calculated per year. And if it's 4.6 per year, this is 4.6 as a decimal divided by 2 to get this rate at the time in which it's calculated for compounding. That will be this value calculated twice a year. So after 6 months and then at the end of the year. The number of compounding periods, N, total, represents the following. It's twice per year for 3 years. So 2 times a year for 3 years, that's 2 times 3, which is equal to 6 total compounding calculations. So here's our formula. We substitute and we solve. So this is how much needs to be invested right now in order to be able to have $6,500 3 years from now.